What if everything you knew about some prehistoric creatures was wrong? From dinosaurs mistaken for turtles to spiders that turned out to be sea scorpions. Today, we're revisiting paleontology's greatest identity crises. Paleontology is a notoriously difficult science. It attempts to reconstruct the lives of extinct animals using only fossilized bones. Bones that are often fragmentary, deformed, or hundreds of millions of years old. Saying this field is challenging would be a vast understatement. Given the complexity, it's no surprise that paleontologists have made some notable mistakes. Most are small, like overestimating an animal's size. But occasionally, an error is so profound that it transforms our entire understanding of the creature in question. These 7 cases offer a fascinating look at how science evolves and how wrong we can be. We begin with an understandable misstep: the Megalosaurus, the very first dinosaur ever described by science. This Jurassic theropod was documented in 1824, a time when the term dinosaur hadn't even been coined. The holotype consisted of a femur, some vertebrae fragments, and part of a lower jaw. English paleontologist William Buckland concluded he had discovered a giant carnivorous lizard that walked on all 4s. To him, size implied quadrupedality. He also believed the animal was amphibious, akin to a crocodile, and estimated it stretched over 40 feet, 12.2 meters long. That estimate didn't last. After a rival paleontologist unearthed an even larger fossil, Buckland increased his estimate to 70 feet, 21 meters, likely influenced by professional rivalry. But the story doesn't end with size. Buckland, a devout Christian, faced a theological dilemma. According to Scripture, death and suffering began only after Adam and Eve's original sin. Yet Megalosaurus was clearly a predator. To resolve this, Buckland proposed that it didn't kill the healthy, it mercifully culled the old and ill to reduce suffering, thus preserving the doctrine of original sin. Yes, seriously. Most of Buckland's original description was incorrect. Over time, more complete theropod fossils revealed that Megalosaurus was a bipedal, fully terrestrial predator, now estimated at half its original size, weighing just over a ton. Still, it ruled Middle Jurassic England as the apex predator of its era. And Megalosaurus wasn't alone. Many early dinosaurs were deeply misunderstood. Progress has been made, but even today, mistakes persist, even with living groups like spiders. In the 1980s, an Argentinian paleontologist discovered a strange fossil in the Carboniferous-aged Baixo de Velis formation. It featured a large carapace, 3 appendages, and tergites, structures found in arthropods. Based on its shape, the researcher declared it a giant spider, Megarachne, the great spider. At 34 centimeters, 13.3 inches, it would have dwarfed the Goliath bird-eater, the largest known spider. Given its Carboniferous origin, a period famed for giant arthropods, the discovery seemed plausible. Megarachne captured public imagination. It appeared in museums, documentaries, and even merchandise. But not everyone was convinced. Its carapace was divided into anterior and posterior sections, and it featured a spatulate telson, traits never seen in spiders. Critics argued these features suggested something else, but the original fossil was locked in a vault, leaving only plaster casts for study. For 25 years, skepticism simmered, until a second specimen was unearthed in 2005. Identical in carapace and appendages, but more complete. Upon analysis, it closely matched Woodwardopterus, an extinct sea scorpion genus. And so the truth emerged. Megarachne wasn't a spider at all. It was a sea scorpion. Not an arachnid, but not too distantly related either. Superficially, the fossil looked spider-like, which partially excused the misclassification. Museums were not thrilled. Many had invested heavily in giant spider exhibits. Some still display it that way today, because they paid for it. But unlike museum fees, liking and subscribing is free and helps support content like this. Today, we understand Megarachne as a sizable eurypterid, sifting freshwater sediment with rake-like limbs in search of small invertebrates. Far from the forest-prowling predator it was once imagined to be. And if you thought that was a dramatic reclassification, wait until you hear how one of the most iconic dinosaurs was once mistaken for a turtle. Our next subject, Therizinosaurus. Thanks to Jurassic World, many now recognize it by name alone, thanks in part to its enormous claws. But it wasn't always the Wolverine dinosaur. In fact, it wasn't even initially classified as a dinosaur. Early paleontologists thought it was a turtle. To understand this, we need to travel back to the 1940s. At the time, paleontology had advanced, but much was still unknown. The Soviet Union, eager to bolster its scientific standing, funded several expeditions to Mongolia's Gobi Desert, a rich fossil site. In 1948, a Soviet team made a staggering find: massive claw bones, each about 1 meter, 3 feet long. These were the largest claws ever found. Alongside them, they found theropod bones and some fragmented ribs and vertebrae. Yet, bizarrely, scientists believed the claws were unrelated to the theropod body nearby. Because the Nemegt Formation was rich in turtle fossils and river deposits, one paleontologist, Evgeny Maleev, theorized that the claws belonged to an enormous aquatic turtle, 15 feet long and over a ton in weight. He imagined it using the claws to rake seaweed from riverbeds. That's not a joke. The species name, Therizinosaurus caleniformis, literally means turtle-formed scythe lizard. Eventually, this theory fell apart. A different paleontologist noted that similar claws were found in theropods, particularly one from China. Gradually, more Therizinosaurus fossils surfaced, this time with leg, arm, and rib bones. These additions confirmed that it was not a turtle, but a bipedal theropod dinosaur. Even today, debate continues about the function of those claws. Proposals include self-defense, digging, food gathering, or even display. But at least one thing's settled. Therizinosaurus was no turtle. Misidentification doesn't stop there. Consider the genus Pterodactylus, the first pterosaur ever discovered. Though iconic today, it was once thought to be a swimmer. The fossil, found in late 1700s Bavarian limestone, was remarkably well preserved. Yet the first scientist to study it, Cosimo Collini, believed it was a marine creature. He was so baffled by its form that he concluded the wings were elongated flippers used for underwater propulsion. He dismissed any relation to bats or birds and didn't even categorize it as a reptile or mammal. Others speculated it was amphibious, living like a seal between land and sea. Eventually, some scientists pointed out the elongated digits and wing membranes, comparing them to bats. This marked the first suggestion that Pterodactylus could fly. Even so, confusion lingered. Georges Cuvier eventually named it in 1809 as winged finger. But debates persisted about whether it was a bat, bird, reptile, or something entirely new. It wasn't until the 1830s that consensus solidified. Pterosaurs were flying reptiles. Today, Pterodactylus is recognized as a small Jurassic pterosaur that lived in coastal Europe, feeding on small animals. Though some of its relatives were strong swimmers, it was never the fully aquatic creature Collini had envisioned. Now, misclassifying one animal as another is one thing. But how about mistaking one creature for three? Enter Anomalocaris. Even with modern understanding, it remains one of the strangest animals to ever live. During the Cambrian explosion, it was among Earth's first apex predators. But when first discovered in 1892, its parts were mistaken for separate species. From Canada's Burgess Shale, scientists found three pieces: a circular mouth, a segmented trunk, and two front appendages. Instead of realizing they belonged to one animal, researchers classified them separately: a jellyfish, a sea cucumber, and a shrimp. It wasn't until more complete fossils were found that scientists connected the dots. Anomalocaris was a single bizarre predator, part of the extinct group Radiodonta, related to early arthropods. The name means abnormal shrimp, and while it's neither a shrimp nor a jellyfish, it is undeniably one of the oddest-looking animals to have ever existed. But misinterpreting fossilized animals doesn't always result from what's found. Sometimes it stems from what isn't. One striking example of a misjudgment based on incomplete evidence is Deinocheirus. Today, it's recognized for its towering height, duck-like snout, and enormous clawed arms. But for decades, it was one of paleontology's biggest mysteries. Discovered in the same Nemeg formation as Therizinosaurus, early fossils of Deinocheirus included only its massive forelimbs, part of a shoulder girdle, several vertebrae, and ribs. The limbs were the largest ever found from any bipedal animal, and they ended in fearsome claws. With nothing else to go on, paleontologists assumed Deinocheirus was a massive theropod, perhaps as dangerous as a T-Rex. The mystery turned it into a legend, touring exhibits and fueling wild theories. Was it a predator, a sloth-like omnivore, a terrifying Slenderman dinosaur with oversized arms used for grabbing prey? No one knew for sure. That changed in 2013, when a more complete specimen was finally discovered. The truth? Stranger than fiction. Deinocheirus was a giant ornithomimosaur, a relative of ostrich dinosaurs, with a long duck-billed skull, blunt claws for digging, and a large sail-like hump. Despite its formidable size, it was likely a gentle omnivore. Its skull shape and blunt claws suggested a diet of plants, but fish scales found in one specimen's stomach indicated some meat consumption as well. At 11 meters, 36 feet in length and up to 6.5 tons, Deinocheirus is the largest known ornithomimosaur and one of the most unusual dinosaurs ever found. A case where mystery and reality were equally astonishing. But fossils don't always mislead by being incomplete. Sometimes we're misled when fossils vanish altogether, only to resurface millions of years later. This brings us to the concept of Lazarus taxa, species that disappear from the fossil record, only to reappear much later. And one of the most famous examples is the Coelacanth, a prehistoric fish thought to have gone extinct 66 million years ago. The first fossilized coelacanths appeared in late Permian formations, over 250 million years old, and were considered transitional species between fish and early tetrapods. They lived for hundreds of millions of years, with specimens turning up in Devonian, Jurassic, and Cretaceous layers. Then, after the Cretaceous-Paleogene extinction event, they vanished. Scientists concluded they were extinct. That belief held until 1938. That year, off the coast of South Africa, a local fishing crew caught an odd blue fish. It was about 5 feet long, 1.5 meters, armored in heavy scales, and had limb-like fins. None of the fishermen had seen anything like it before. A museum curator spotted the specimen, sensed its significance, and contacted ichthyologist J.L.B. Smith. Upon seeing a sketch of the fish, Smith was stunned. It resembled a prehistoric coelacanth. He urged the curator to preserve everything possible. After receiving fin samples, Smith confirmed the impossible. This was indeed a living coelacanth, a Lazarus from the depths. The discovery sent shockwaves through the scientific world. Expeditions were launched, and soon, a second species was found. Today, 2 types are known: the West Indian Ocean coelacanth and the Indonesian coelacanth. These modern coelacanths can grow up to 2 meters, 6.6 feet, and live for nearly a century. Their genome has been sequenced, and surprisingly, they're still evolving, despite their ancient lineage. Their reappearance reminds us just how little of Earth's oceans we've explored, only about 20%. In those unexplored depths, creatures from deep time may still survive, waiting to be discovered. And if that fascinates you, check out my other video on deep-sea giants over on Living Zoo. The link's in the description. Subscribe for more deep dives into ancient life and unexpected truths from the fossil record.